Hi, I am Cal Rooks. I'm the guy from Seattle, the physics geek, wannabe geek, who Sunday, May 29th, while sitting in service, Salvation Army, did think quite some thoughts about what a tornado was. And I actually came up with a new theory of what it was, what caused it, and stemming from that, a initial solution and some ideas for some more. So basically, in the last month and a half, I've developed an awful lot of remedies for stuff anywhere from hurricanes, theories of what a hurricane actually was stemming from this theory, series of ideas of how to mitigate tornadoes of different types, several different ways actually. The problem, I guess, is that it's a little bit hard to believe that something this simple could be actually true. So that's what I'm going to do. I'm going to try to present that maybe a little bit more developed, some new ideas that have occurred to me since then as to what's going on and what happens when an air drain forms and essentially forms a wind vortex through it. So with that, I'm going to begin on general theory of vortexes, and in particular wind vortexes. So basically, fluids spin because they go down a drain. Period. With that, I'm done. It is the drain that does it. Okay, so now how do I prove that? What I'm going to do is actually go over there's actually three forces that I can identify that cause stuff to spin when they go through a drain. I'm going to begin with what I started with originally. I believe that all wind vortexes are boiled down simply caused by a warm air mass or bubble of whatever size and shape and pressed down by a cold air blanket above, and thus under pressure tend to spring one or more leaks. With the warm air rushing upward and the cold air pressing all around, it forms a pipe similar to a drain pipe. And you're in your house and spinning water that goes down your drain. The obvious difference is that the air is going up as the drain is inverted. So a waterspout, hurricane, tornado, or other wind vortex occurs to bring equilibrium to this unbalanced situation, namely cold air on top of lighter, warmer air. The tornado, for instance, empties the air bubble and is spent. It's over. My theory says that waterspouts that look like they start on a calm lake are really starting from up above, where air is penetrating the cold air above and spinning until the funnel reaches the water. And as it touches down, it begins to move the surface, and then more strongly, as more wind and vacuum of the vortex keep developing downward, the force of course spinning and sucking upwards. So the vortex forms from the hole and then pipe form in the layer of cold air above, and the warm air rushing up from the pressure built up by the weight of the cold air around it cause the well-known spinning that works its way down until it touches the ground, the lake, or the ocean. And with that, I'm basically done. Wind, pressure ridges, wind shears, rain, dust, everything factors in and are why tornadoes move, even just to follow their own supply of warm air as they empty the bubble. But the cause is this and this alone. So, what I'm saying is that a vortex of any kind is formed because it goes down a drain, or up a drain, or through a drain. Whether it's forced to do so by gravity or some other kind of force like pressure. And you can probably extend this to things that were not even molecular. You probably could extend this to other forces as well, like electromagnetism and stuff like that, I have little doubt. So anyway, I'm going to identify three forces. I mean, probably way back in high school, which is about as far as I got, believe me, with physics. I mean, college didn't really do me much good. So I basically have what amounts to an excellent high school education in physics. And I think back then, thinking about vortexes or drains spinning down, I thought of friction coupled with gravity was kind of the chief moneymaker for a water drain going down your kitchen sink. That friction tends to work on stuff that's going faster more, so it's going down strongly and it's impeded more. Any sidewise motion that it has is impeded less, and that just kind of builds a cycle that keeps on going until those forces balance out. And that was kind of an ancient thought of mine about what forms a drain and a spinning drain. So actually you do find that air does have friction. If it's small particles of air that are being considered and they're moving relatively slow, it forms rather a small linear equation. And if those forces become faster, then that equation doesn't hold, those forces become far greater. And I believe they do have a small part to do in possibly starting drains when they're still. Matter of fact, some people did an experiment with a water drain trying to see if the Coriolis effect, maybe I better say Coriolis effect, actually works to spin drains counterclockwise in the northern hemisphere. So they let the water sit in the bucket for a week until it was completely still, as best they could do. And they pulled the cork from underneath, the water went down, it took it a while, but it did start spinning. They described the force as rather weak, whatever that meant. So there is that kind of force, but there's another force. That's about the only one. As I searched for answers online, I didn't find really much of great knowledge about why things spin in a drain. But there was discussions of angular momentum, and angular momentum truly is one of the greatest forces involved in spin and drain. And fortunately, in a tornado, for instance, there is great angular momentum. It doesn't have to be spinning, it just has to be moving across the drain. If you have spinning motion in a drain, we're done? Are we done?
No, this is good. This
okay, well just tell me when we're moving close to 15 minutes. Good. What time we got right now?
It's 8 minutes.
8 minutes, okay. All right. Okay, so where was I? Okay, angular momentum. Okay, if you get a skater, for instance, they point to a lot, and everyone knows this one. When a skater starts to spin, and they got their leg extended, they got their arms extended, and they're kind of going a little bit slow like that. And then all of a sudden they pull in their leg, they pull in their arms, and boom, they go like that. They go like a top being pulled. Now this is what is happening as angular momentum is being converted to circular momentum down through up a drain. It's pulling in those arms and legs, and all of a sudden everything's spinning fast. So in fact, one morning I rushed out and tried, hey, there's that equation in that hyperphysics thing or that other physics thing, and looking at that I said, well, the speed for conservation of angular momentum is directly inversely proportional to the radius. I thought, well, okay, what does that equal? So, oh, wow, man, that was simple. If you half the radius, you double the speed. And I said, well, wait a minute. What does that mean? Double the speed angularly, vectorally, longitudinally? What are we talking about here? Well, it's just said perpendicular to the axis. Okay, well, man, that's 100% in this case. So at any rate, it's going to double the speed. Well, that seems kind of counterintuitive. I mean, if you think about the ball that was all of a sudden on a tether around an axis point, you think, hey, no sideways forces, nothing wrong, it's just a smooth operation. Perfect bearing, no gravity, just the force, okay? It's going around. Hey, that speed is not going to change, but of course it is now going to go around the axis point rather than straight on through space. Now the theory says that if you half that radius, you are going to double the speed. And I thought, well, that doesn't seem intuitive. I mean, you would think that it would just go the same speed, but because it's got a smaller radius to go around, it's going to travel around with more RPM. But in fact, that is not the case. It's going to double its speed. And if you stop and think, well, wait a minute, when I was a kid, I was on a merry-go-round, I used to spin them around pretty fast, and then I used to just love to see them go spin faster and faster, as with all my might, it took all my might, I would move myself toward the center until I reached that magic point. It used to take all my strength as I'd be going fast, and get in that center where those forces would cancel out, and there you'd be, maybe a little dizzy, but just looking at everything, you know, and having fun. And that is, when you stop and think about it, work. And force applied over a distance. So you pull in that string on that ball, and yeah, you've applied work to it, which is going to accelerate that ball until it finds that new velocity, which, according to this formula, is double what you had when it was out at twice the radius. So as you can see, that's going to really greatly accelerate any angular momentum forces, which are certainly there in the wind around it. There's some kind of wind, greater or lesser, that's just moving across the hole. It doesn't have to be going in a circle. And there you get the angular momentum. Thirdly, okay, take the water drain. Gravity is pulling that thing down the tube, right? Obviously, we're all going down the tube here. And so anyway, there's a vector of that gravity that's going towards the, that's going with the rotation of the spin. So gravity is also accelerating the spin of the drain, or the vortex.
1 minute.
1 minute. So here I've identified a lot of forces that are going to spin that thing up to where you're going to get a tornado out of a drain. I'm going to take a break. We're going to come back. We'll do more. Thank you. Turn it off.